All right, there we go. It's top of the hour. It's 11 a.m. where I am in Texas. So let's go ahead and get started today. Welcome everybody to our webinar on KNIME text processing. My name's Scott Fincher. I'm the data science community manager at KNIME. I've been with KNIME for almost 5 years now, teaching a lot of our courses and helping to build up our community, posting on the forum and stuff. You may have seen me there. So glad to be with you today to talk about text processing. Also with me today is Elizabeth, or we call her Lisa Richter. She's our data science publisher. Lisa, you want to say hi right quick?
Hello, everyone. I'm very looking forward to this hour now. I'm glad that you're all here. As Scott says, already said, I'm working as a data science publisher in the evangelism team and mainly focusing on the KNIME Press.
Great. Well, thanks, Lisa. We'll hear more from her in a little bit later. Let's go ahead and get started with our content today. So what's it going to look like? We're going to have about 45 minutes of presentation for you on text processing, how we approach that in KNIME. And then it actually probably would be a little bit more than that. We'll try to reserve the last 5 or 10 minutes for questions, though. Hopefully you will have questions as we go. And if you look in Zoom at one of the buttons that you have at the bottom is a Q&A button, and that's where we want you to ask your questions. So Lisa and I, as we trade off in the presentation, we'll try to be answering your questions in the chat, but we'll save some good ones for the very end where we can address those live. One thing that everybody always asks is, will the session be recorded? The answer is yes. We'll post it on YouTube. Usually takes us a couple of days to do that. And we will also post the slides and the workflows that we talk about. The slides will be on the KNIME forum, and the workflows will be on the KNIME Hub. We've already got a link posted in the chat. Thanks, Shantanu, for the link to the forum thread about this webinar. That's where all the resources will show up. Just as I mentioned, give us a couple days once we're done to have all that there. And if you have any follow-up questions, you can post them in the thread and we'll be answering them as well. So just a little housekeeping there before we get started. What are we going to talk about today? Well, I'm going to start with the philosophy of text processing and how we specifically approach that in KNIME. And then we're going to have several example workflows for you. So we're going to have a sentiment analysis example where we classify some movie reviews as being positive or negative. I'm going to hand it over to Lisa, and she's going to talk about topic analysis and give you an example of that as well. And then we'll circle back around at the very end and show you some live social media analysis of tweets using a data app that we can run in the KNIME web portal. After we've shown you those 3 examples, we'll have some time to give you some additional resources, link to a book on text processing that we'll make available to you, and then again, time for questions. So that's where we're headed today. Hope you'll be with us for the whole time as we go. All right. Before I do get started on talking about sentiment analysis, though, we're not going to cover everything, all use cases that you could possibly do with text processing. There's lots of stuff. So if you find yourself having to deal with things like, I need to extract data from PDFs or tables, maybe you need to do optical character recognition, maybe you even need to go a little deeper with some active learning or deep learning for natural language processing, we do have workflows available that cover those topics and go into a lot of detail. It's just not something we're going to have the time to talk about today. So if you tuned in hoping to hear about those things, sorry to disappoint you, but know that that is something that KNIME can do, and we're happy to provide you with some additional resources on the back end to get you started there if you're looking to do any of those. Okay. So first, I want to talk about the philosophy of text processing. My assumption here when I'm giving this talk is that many of you have used KNIME before, but maybe you've never actually done any text processing with KNIME. So you know about nodes and connections, maybe even flow variables and some things like that, but you haven't actually downloaded the text processing extension to attempt this type of analysis. So I'm going to go through the basics of what it looks like. Then we'll talk about some of the nodes that support each one of these bits that you see on the screen here, and then we'll move on to the examples. So what is this slide? We've got these 5 bubbles here, and they represent the 5 steps of text processing. So starting at the top left, you see, basically what does this represent? This represents ingesting data, reading data into KNIME. So if we have text that we want to process, it's going to come from any number of sources, right? It could come from PDFs, it could come from Word documents, Excel, it can come from free text, it could come from tweets, right? All sorts of places we could get data. But the point is, we have to get it into KNIME first, and we have dedicated nodes that will help you do that and convert it to something called a document form, which is going to be critical for any of the nodes that we use in text processing. They all rely on documents. I'll talk about that more here in a second. So once we read the data into KNIME, that's the first phase. The second phase is something called enrichment. You might also hear me refer to this as tagging. The idea is that we're going to add additional information to the text that we're trying to process that will help the process along, basically. So if I have something like perhaps your name is Rumpelstiltskin, then the sentence fragment, I could tag Rumpelstiltskin as a person. I could also do other types of tagging. I could tag parts of speech, which we'll do shortly. I could tag sentiment as words that have a positive or negative connotation. All sorts of tagging I can do, but we want to add additional information to our text, again, to help the process along. Once we do that enrichment phase, then we move to this top bubble in the middle, which we call the pre-processing phase. So the idea here is, text that we're going to bring in, human readable text, is super complicated, right? There's tons of information in it. And the number of words and terms that we have in there oftentimes can be a little bit overwhelming for a model that we want to build. So we want to boil down or reduce the feature space of our text to make things simpler for the model that we're going to train. So what does this mean, practically speaking? It means we're going to filter things, more or less. There's more than filtering. There's things like removing punctuation. There's some stuff like stemming and lemmatization that I'll talk about. But a lot of this is filtering and removing unneeded terms or words to make our feature space smaller. Once we've done that pre-processing, step number 4 here, we call transformation. So that's the idea of converting human readable text to some mathematical representation of our text. Usually it's going to take the form of a sparse document matrix. I'll show you what one of those looks like here in a little bit. But you might think of it as just a matrix of ones and zeros that represent different terms in our text for each document that we're going to look at. Or I say document, but it could be tweets or abstracts or whatever it is, right? So we're converting from English to a matrix, some mathematical representation. Now, once we have the data in that form, we're almost home free because we can take that matrix and feed it into any number of existing algorithms that we already have available to us for doing things like classification or clustering or generating visualizations, making a word cloud, something like that. Nodes that already exist in KNIME that can work with that type of data. So those are the 5 steps. And let me show you some of the nodes that we're going to use in each one of these steps before we go on to the actual example. Before I do that, actually, I want to talk about a couple of things here. There's 2 data types that are important for text processing in KNIME. If you've used KNIME before, you're already familiar with things like strings and integers, longs, doubles, different types of numbers. If we're going to be processing text in KNIME, we need to keep in mind 2 additional data types. So one is called a document. What is a document with respect to KNIME? Well, it includes lots of information. It includes not only the text that we're actually going to be processing, but it also includes other meta information. So we can store, in addition to the text, the title, if it's an article or a review that we're looking at. We can store the source of the data. We can store the author who wrote it, when it was written. Importantly, for classification, we often want to store the category of the document. So if it's a restaurant review, maybe we want to store whether it's positive or negative, or we want to store what type of review it was. It was from an Italian restaurant or Chinese restaurant, right? We can store all of that information within the document. So when you see a document and it's going to be represented in a KNIME table with this little page icon, know that you're seeing the title. That's all you're going to see in the KNIME table, but there's lots of other stuff that's contained in there. So don't be fooled by that. The other data type we want to look at is called a term. So KNIME uses a composite data type to represent certain keywords from our text. So basically a term is 2 parts. It's going to be the word itself and some tag. What can the tag be? I mentioned those when we talked about enrichment before. You could tag according to sentiment, part of speech, city, somebody's name, is it an organization, whatever. An example of this in KNIME, if you look on the right-hand side, I have words in this term column. Here's the word very that has been tagged as an adverb, part of speech tag. Similarly, the word good has been tagged as an adjective. These little codes here correspond to different parts of speech. But this doesn't have to be parts of speech, right? It could be sentiment. It could be one of these other things. The idea about a term is that it contains both the word and the tag stored in the cell, okay? So that's also important for some of the nodes that we're going to use later on. Okay, now that we are keeping that in mind, let me talk a little bit about where we're going to go today. Oh, this is actually the last thing that we're going to show you. I'll give this to you up front so that you can be thinking about this when we get to the end. One of the things we're going to do is build a workflow. It's already going to be built. I'm going to show it to you. And what that workflow is going to do is classify live tweets according to whether they are positive or negative, give us a word cloud of what's contained, and then a table of the actual tweets. We're going to run this on a KNIME server as a data app. So this is a way, data apps are a way that you can make accessible your workflows to somebody else who may not know anything about KNIME or sentiment analysis, but they can actually run the model, classify the tweets, and derive some information that is useful for them. So this is the last thing we're going to see today. But before we get there, we need to see some of these nodes and how they work. And so that's what I want to talk to you about next. Okay. We're talking about sentiment analysis. This is going to be our first example, and we're going to use movie reviews to do it. So we're going to have 2,000 different movie reviews we're going to look at. 1,000 of them will be positive and 1,000 negative, split right down the middle. And we're taking them from IMDb. So there's a few ways we could build models to be able to come up with the sentiment, whether somebody thinks this is a good review or a bad review. We could take this lexicon-based approach, which you see on the left-hand side. This is a little bit of a simpler approach in that we basically would take a list of words that we know have positive or negative connotations, and we would tag our text with those good and bad words, and then count how many good and bad words are in the review, and then score it. So that's a little bit of a more primitive approach. Sometimes you might have to do that if you have a list of reviews that aren't already labeled. But since we have labeled reviews, we're actually going to take the middle approach, the machine learning approach, to be able to train models that way. If you wanted to get really fancy, you could also use a deep learning approach. You could build out a neural network using KNIME nodes. We're not going to do that today because it's, number one, it's too complicated, and number two, our data set is not large enough to support that. You probably want hundreds of thousands or millions of records for a deep learning approach, and we only have 2,000. So if you're interested in these other two approaches, though, that we're not going to talk about, in the workflow package that we'll upload to the hub, we'll provide sample workflows and instructions on how you could build these other two out as well, just so you can see the difference in the way these are structured and how they perform. But we're going to stick to the middle one for now. Okay. In the bottom right-hand corner of these next 5 slides I'm going to show you, this is a little mini version of the workflow that we'll see in the demo. And I'm going to show you a bit about the nodes in each of the 5 sections of the workflow. So the first, the philosophy slide I showed you, we had 5 different bits, right, about how we approach these. Each one of these sections in the workflow corresponds to each of those 5 steps. So part 1 here, I mentioned before, first we have to get the data into KNIME. You're probably already familiar with nodes like the file reader or the Excel reader or the table reader to bring information into KNIME. We have lots and lots and lots of readers. You see some of them here. They're mainly orange in color. That's the color scheme. In our example, we're going to use a file reader to read in these 2,000 movie reviews that I've already prepared. Really, the most important node on this slide is actually here, the strings to document node. We have to take whatever strings that we have, whether they come from PDFs or a table or whatever, we need to convert them to documents, because downstream, all of these other nodes that are going to be used to do the analysis here require the document field. So strings to document is going to convert that for us, and I'll show you how that works in the example here in a second. But first we read in the data, strings to document, and that's going to make up the majority of what we do in part 1. In part 2, this is where we do the enrichment or the tagging. In our example, we're just going to use what's on the right here. We're going to tag with parts of speech. There's lots of other ways we could tag data. As I mentioned, if we took this lexicon approach, we could tag words with positive and negative tags according to their connotation. We could tag terms with an NLP named entity learner that looks for things like people, places, or organizations. There's other taggers here that are specific to the biochem world that you may not ever use. We just list some of the different taggers here so you'll know. But we're going to just do only, in our case, the part of speech tagger, the POS tagger. Now, why are we going to do that? Well, ultimately, if we tag the words with their parts of speech, then later on, we can say, hey, you know what I'm really most interested in here are things like nouns, verbs, adjectives, maybe adverbs, all the other stuff I don't care about. And so we'll filter things according to the tagging that we've already done in an effort to reduce our feature space. That's what we're going to be doing at the end of the next step, which is part 3. Part 3 is pre-processing. What is this about? Cleaning our data up. We have several different nodes here. I use, I think, 7 of them here in this example, and they do basically exactly what they say on the tin, right? Punctuation erasure. You can imagine what that does. It gets rid of the punctuation. Why? Because it's not important, usually, for what we're trying to do. Same thing with getting rid of numbers, getting rid of small words, getting rid of stop words. What's a stop word? That's kind of a term of art we use in text processing where think in English, right? Words like a, and, the, but, to, who. Those are all really small and unimportant words that for the purposes of what we're doing, classification, don't really shed any light on, a movie review, right? They don't tell us anything. Let's get rid of them. All about reducing our feature space to shrink things down so that our model will perform better. We can do case conversion. You see here, number 5. Why do we care about that? Well, in English, we capitalize the first word of a sentence, right? Well, we don't want a non-capitalized word to be treated differently from a capitalized word, so we can just convert the case, and again, makes things a little simpler. This next to last one here is the snowball stemmer. There's several different stemmer and lemmatization approaches that we could use. What is stemming? I guess, first of all, maybe it's useful to explain that briefly. Stemming is the idea of reducing different words to a common form. So I like to use the example of the word dance. Dance is a noun. We could go to a dance. We could also dance ourselves, which is a verb. And then there's other forms of the verb. Maybe we danced in the past, or we will be dancing presently, right? All of these different forms of the word dance. What's the idea that those words convey? Dancing, right? And so we don't need to keep all these different forms of the word. If we instead stem to something like D-A-N-C, that's no longer a human readable word, but it conveys the idea. And we shrink all of those terms down into a single term, which helps us again when we're pre-processing and boiling down. So that's what stemming does. There's different approaches to that, as I mentioned, but we're going to want to do that. And then again, at the end, we filter. I alluded to this before. We're going to filter out anything that's not a noun, adverb, adjective, or verb. All of this pre-processing stuff that you do, if you do it in a bunch of different workflows, you may find that you take the same approach over and over again or something pretty close. So what you could do is take all of these different nodes and collapse them into a component. I could collapse this into a component called Scott's pre-processing approach or something. And then I could save it and use it in my future workflows so that I don't have to build out and configure all 7 of these nodes every time I want to do this step, right? I could then just drag and drop my component into my workflow and save myself a bunch of time. So you may want to consider doing that with pre-processing in particular, because it can be kind of repetitive. Okay, let me keep going here. Step 4, transformation and frequency. So what was the idea here? Converting from human readable text into a mathematical representation. We don't have time in this webinar to go into all the details of bags of words and term frequency. The important one here is the document vector. For our purposes, the document vector is going to take all of these incoming documents, in this case, 2,000 movie reviews, and it's going to take all of the different words across all of those different reviews, what we would call our corpus of reviews, and it's going to create a matrix. And the matrix is going to contain columns, 1 column for each term in our data set, and 1 row for each movie review. So we end up with about 20,000 words. So we're going to have 20,000 columns and 2,000 rows. That's a big matrix. And it's going to be filled with either zeros or ones in this case, which is going to indicate whether a particular word exists in a given review. This is a little bit hard maybe for you to visualize when I'm just talking about it. So I'll show you what this document vector matrix looks like here in a second so you can see what I'm talking about. But the idea is, again, we have a big matrix. It's a mathematical form that we can then use with our existing KNIME nodes to build models and classifications, and that's what we end up doing in step 5. So you can ignore the left-hand part of this slide since this is for the lexicon-based approach, which we won't use. But in the machine learning approach, we're going to do what we always do when we build models in KNIME. We're going to partition the data into a training and test set. In this case, we use a fairly simple decision tree learner and predictor to build a decision tree model and then apply it. And then once we have applied that model to our test set, then we can score the results and see how well our model performed. So this is all pretty standard machine learning stuff that we would do in KNIME. And at the end, we can say, okay, our model is, 85% accurate with, such and such false positives, right? We could look at all that stuff, and I'll show you that, in fact, here in a minute. Let me check my time real quick. Okay, so these are the different nodes that we use for the 5 steps in our text processing approach. Now, how does this actually look when we take a look in KNIME and see how things are going? So let me shift over to KNIME and show you what was before a static screenshot is here the actual workflow. Now, I won't take time to go through every single one of these nodes. I just want to show you some of the important ones. I will start at the beginning and show you what our reviews look like. If I've already executed all of this, but we read in our data with the file reader, and then I have, a table like this. It's got some index number, a URL where the review came from, the actual text of the movie review in this middle column, and then all the way over here at the end, it's got, let's see, the screen, there we go, the sentiment, positive or negative. It's 1,000 POS, 1,000 NEG. That's what we want to train our model to detect. Now, I mentioned the strings to document node. This is one of the most important nodes, in my opinion, in the text processing extension, because, again, we need to convert to documents to be able to do anything else downstream. So here we say, our text comes from the text column. Our title, we didn't have a title in this case, so we assigned it to be an empty string. If you had a title to an article or an abstract or something, you could include that here, and it would also be parsed as part of the document. And then we can also store, the URL as the source. Very importantly for classification, we want to store that category, that positive or negative, in there as well. We're going to pick that up from the column called sentiment. And then the rest of these options we'll just leave as default. So once we've converted to a document format, and I basically filter out everything except the document, I want to show you something, because sometimes people get confused about this when they look at it for the first time. They look at their document in KNIME and they go, oh, I messed something up. I did something wrong. I look at my document column and there's nothing here. It's just a bunch of blanks. Don't be fooled though. This is blank because we set the title to an empty string, and KNIME represents a document in a KNIME table by showing you the title. So it doesn't have a title, therefore there's nothing to show you, but the text and the category and the URL and all that stuff is actually stored in here. Now we can actually see that using a different node here in a minute, which I'll show you, but just don't be fooled by the normal KNIME table when you look at this and go, oh no, I did it wrong. You didn't do it wrong. It's just how KNIME shows these things by default. So part 2, enrichment, this is where we apply the parts of speech. Sometimes it can be confusing at first after you do something like the POS tagger or one of these other pre-processing steps. How do I know that what I did is actually being applied? So this is where I can do something. I can use the tagged document viewer to essentially check my work as I go. This tagged document viewer has an interactive view. And what it's going to do, since all I've done at this point is applied parts of speech, is it's going to show me, okay, here's the very first review. And all of these different words have tags now. So here's a named noun. Here's different forms of verbs. Here's an adjective. We got adverbs in here. All of this sort of stuff, it just lights up like a Christmas tree to show you all the tags. So this is, I just wanted to show you, and I could look at, multiple different reviews in here if I wanted to. The point of this is, are my tags being applied? Yes, they are. I can be confident and move on to the next bit. So the next bit in this case is going to involve all the pre-processing we do. I'm not going to show you all of these different nodes because, again, I think it's fairly explanatory what they do, but maybe one useful thing to show, and let me get rid of some of my Zoom windows here, at the very end would just be to verify, there we go, did all of these things that I did take? right? After I applied my tagging and case conversion and stop filters and all that, did this take? So I want to show you what things look like after we've done a bunch of cleanup. Again, using another tag document viewer node. So I'm just running this right now, and you can see for that first review, things are a lot simpler. There's a lot fewer words for one thing, and we also have a lot of stemmed terms. So you see the word futile in here, F-U-T-I-L. That's not actually an English word, right? You can tell it's a stemmed word. Same for purpose and technique, right? So we've lost all of the words that are not nouns, verbs, adjectives, and adverbs. We cleaned up a bunch of those short words that we know don't contain any meaning. So there's a trade-off here, right? This is less human readable, but we're trying to boil things down for the sake of our model, right? And this is what we're going to do. We're going to use this text instead to do the classification, just what we have here, not the entire review. Okay. Checking time again. I'm running a little bit behind, so I'm going to go through this last part fairly quickly. After we have cleaned up our data, we build this document vector that I mentioned before. What does that look like? Up here, you can see we have the 20,000 columns. If I scroll over, it's a really big table. And we have these stemmed terms across the top. We have all 2,000 of our rows corresponding to our reviews on the left-hand side, and then just a 1 or a 0 indicating whether this term appears in which document. So this matrix is mostly full of zeros, right? Mostly. But it has a few ones scattered in here. This is our mathematical representation now of our data that we can use to build our model. And that's in fact what we do next. We do our partitioning, like I mentioned before, build the decision tree, apply the decision tree. I assume most of you have probably done some of this before if you've used KNIME to build simple models. And then we can look at the results using this binary classification inspector, which is going to tell us things like, okay, the area under the curve for this particular predicted model is about 0.9, which is pretty good. It's not perfect, right? But no model is perfect. But it's also not suspiciously good. It's just good. We could look more specifically at our false positives, true positives, false negatives in the confusion matrix over here. This binary classification inspector gives us lots of ways. We could break down additional stats here if we wanted to see the precision and sensitivity and so forth. In an interactive way, we can look at the results of our model. But the idea is that we've built a model that will predict now with about 90% accuracy-ish whether a given movie review is positive or negative. And we could take the model we've built and feed new movie reviews into it that have been unseen and feel pretty confident that it's going to do a good job of classifying them. Okay, if you want to play around with this workflow more on your own, we'll post a link for it so that you can do that. But I'm going to stop where I'm at for now, since I'm at 27 minutes already. I'm going to hand it back over to Lisa, and she's going to talk to you a little bit about topic modeling.
All right, let me just quickly share my screen. So you should see all my slides now. So in this part, I'm going to talk about a different type of text analysis, which is called LDA. LDA is a method to extract topics from data. And to understand this a little bit better, I'll also quickly talk about clustering in general. So what is clustering? Clustering is a method that groups together objects in a way that objects of the same cluster are as similar as possible, and objects of different clusters are as dissimilar as possible. So it is an exploratory method where you have a data set and you don't know ahead of time what the labels are or what the groups are. And this is in contrast to classification, where you essentially know the answer ahead of time already. So with the clustering, what you can do is, for example, you can try and explore your data set and find documents that are closer or more similar to each other than other documents in your data. Or what you could also do is to detect topics based on the words that are already in your document or in your data. So in general, clustering is an unsupervised learning approach, and there are different nodes in KNIME that support this type of analysis, and I will also show you an example later. And what you see here on the right is a two-dimensional representation of a multi-dimensional problem, so that we can actually visualize it. And here we like with this kind of color coding, you can see which documents are more like which other documents in the data set. But I'll get more into this in a minute later. So talking about visualizing clusters, there are different ways how to visualize clusters in KNIME. This is more general, so it's not only in the text processing, but in general for any type of clustering. I just go very quickly over this though. So for example, if you do a hierarchical clustering, you can plot a dendrogram, which you can see down here. Or if you do k-means or k-meteoids clustering, you can plot it in a scatter plot and detect your clusters here. One thing I want to highlight here is the Tease algorithm, which is not clustering itself, but it is a way to take a super high dimensional data set, and then you can boil it down to just 2 or 3 dimensions so that, so that we humans can actually visualize it. So it is basically a method to visualize clusters. So these are all the things that we can do in KNIME, where we have nodes for. But what I want to talk about particularly today about is topic modeling in the text mining arena. So now the question, what is topic modeling? So topic modeling is a process to discover topics in a group of documents, or what we might call a corpus. And when we're looking at topic modeling models, we basically make 2 assumptions. So one assumption would be that each document consists of a mix of topics. So that means if you have an article, for example, which is your document, it is not only about one thing, but about multiple things. And then the other assumption is that each topic can be explained by a collection of certain words or terms that are associated to this topic. I'll show you another slide in a second, which explains this a little bit better. So the topics themselves, they are kind of hidden within the document. So the algorithm can assign different topics, or basically you tell the algorithm, hey, I want to please find five topics, and then the algorithm goes and defines 5 topics for you. However, the algorithm does not really know what the topic is about. So it can't go and find a group of documents and say, okay, this group of documents is about politics, and this group of documents is about food or whatever. It can't do that. All it can do is define topics, find topics, and then give you a list of words or terms that is associated with that topic. So what you have to do in the end is to look at that list of words and then interpret these words and find what is the topic representing in the end. So this is on you in the end. So what is the whole point of the topic modeling? So the whole point is to use the algorithm to discover the topics so that then we can go ahead and interpret them and pull out the meaning or the semantics from our corpus. And to do this, we use a tool in KNIME, which is called LDA, which stands for Latent Dirichlet Allocation. And I don't want to go into too much detail here, but what we know and what is important is that the LDA is an unsupervised learning approach. And what we are trying to do is that we are taking some training data, and we're trying to identify some stuff about the underlying data distribution by generating some samples. However, I want to show you this slide because I think that just makes it a bit more clear what I just said. So what you have is you have a set of documents, which you can see here in the top row, and you have a bunch of words here in the bottom row, which are contained in those documents. And then the algorithm tries and pulls out the weights from which we can then infer the topics. And maybe the slide makes it even more clear or explains it a bit better. So what you can see here is the actual output of the topic extractor parallel LDA node in KNIME. And you feed it in like a bunch of documents, and this node outputs 3 tables. So here, the table on the top contains a collection of probabilities for each document. So as I said earlier, you have to tell the algorithm how many topics you want to find in your corpus. And then the algorithm goes ahead and assigns for each document a probability for all the topics. And usually you have like 3 or 4 topics with a relatively high probability, and all the other topics are usually close to 0. And then in the end, the algorithm assigns your document as the topic with the highest probability. However, by looking at this table up here, we still don't know what the topics actually are about. So that's why we have this second output table, this topic terms table, which is shown here on the bottom left. And this is basically just a list of terms that are associated to each topic. And like if you look at the screenshot here for topic 0, for example, there are words like firm, investment, market, or performance, stuff like that. So what you're going to do is you look at these words, and then you can decide, okay, topic 0 is probably about some market investment stuff. And if you look like that, that's what this topic represents, so to say. And if you look at a different topic, then at topic 1, there could be totally different words in there. And by that, you have a totally different meaning for a different topic. So, and the third table, actually, it's the iteration statistics. Usually we don't really care about that table, but we just have a look at it in case the algorithm doesn't converge for some reason. So that's about it, but I think maybe it's just easier to understand when we're looking at it in KNIME. So I'm also just going to switch to the KNIME Analytics Platform and show you a workflow. So this workflow here, it has the overall goal to read large amounts of data and then identifies the hidden topics in your data set. And this eventually allows us to then only concentrate on a subsection of our data, because, for example, we can say, okay, I'm only interested in that part of the data set that belongs to topic 5, for example. So this is what the entire workflow is actually doing. Here in the beginning, we have a component that reads in our data and also is doing a little bit of preprocessing. I won't go into detail here, but what we have a data set with medical abstracts we took from PubMed, which is a freely available open source data source that contains tons and tons of medical abstracts. We read 1,500 abstracts here of 5 different diseases. We actually have the diseases in this PubMed query here. So, and we feed this information into our topic extractor parallel LDA node. So what we need to do here is we first need to specify our data source column, which is in this case our preprocessed document. As I said, we are doing a little bit of preprocessing in the component already. And then we also need to define the number of topics and the number of words per topic. So this is something you necessarily don't know ahead of time. Maybe you can make a good guess here. For example, in our case, a natural guess would be to have 5 topics because we have 5 diseases in our data set. But for the sake of this example, I just search for 8 topics. And we just say we want 20 words per topic, but maybe it would also work with 10 or even only with 5 words. And then there are 4 more parameters, which are some hyperparameters of the algorithm. The default values, I just leave them here as the default values. They usually do a pretty good job, but in case your model does not converge, then you might need to change them. All right, and then you can look at the results to see if the parameters you defined were good. And let's look at the first table, the document table with topics. So this is basically all the documents we have. And the interesting part is here on the right side. So we defined, or we said to the LDA, hey, we want to find 8 topics, and that's why we have 8 columns with probabilities. So what does that mean? Now, looking at the first document, at the first row, this basically says that 98% of our first document refers to topic 7. So it assigns topic 7. It's the highest probability. Looking at the second document, however, it's kind of like split almost half-half between topic 5 and topic 7. But because topic 5 has a slightly higher probability, the algorithm assigns document 2 to topic 5. Now, as we still don't know what our topics are, as I said earlier, we have this topic terms table here. And this allows us to, just have a look at the topics in more detail and what words are associated with those topics. And what you can see here for topic 0, for example, by the way, those terms are sorted descending by weight. So the more important terms are upper and less important terms are lower. So looking at topic 0, we have words like gene, cancer, disease, stuff like that. So we can now decide, okay, topic 0, probably about some type of heritable cancer, maybe. This would be one thing. Then if you look at the second topic, like topic 1, you have totally different words. There you have words like diabetes, mutation, patient, stuff like that. And there you can decide, okay, then, well, maybe topic 1 is about diabetes. One thing though, as you might see, these, like, sometimes it's clearer what the topics are about, sometimes it's less clear. This is just something you have to deal with. Unfortunately, that's just somehow also the nature of the LDA. You do have those terms, and what you could do is if you change the number of topics or the number of words per topic, then you might get a better idea how your documents are split. So what I do next in this particular workflow is I use the Tease algorithm I mentioned earlier to reduce our data from our 8 dimensions, because we have 8 probabilities. So I reduce it from our 8 dimensions to a 2-dimensional representation, just to make it easier to plot it in a 2D scatter plot. One last thing what I'm gonna do is I assign colors to the diseases we already know exist in our data set. And then I plotted using this component here, which we specifically built for the plot. And you can see a bunch of things here. So what you see up here is the representation of our reduced data set, and the colors are, just to repeat it, the colors are the different diseases. And you can see that most of the data points are scattered close together. So all of the orange ones are down here, all of the yellow ones are over here, all of the green is here. Only the light and dark blue ones are scattered through the different topics. Then what you can do here on the right is you can select specific topics, for example, topic 3, then all the yellow data points light up, or you can select also multiple topics, then all the selected data points light up. So for this purpose, I will just deselect topic 3 and will continue only with topic 7, because I'm particularly interested in that. And then down here, you have some more information. You see the document that are assigned to your topic that you have selected, and you see all the terms that are assigned to your topic. And that's probably the more important part here. So just for the next step, as I said, I select topic 7 and I want to continue with my analysis. I click that close and apply temporarily here because I now want to look at a word cloud for the words that are assigned to topic 7 only. And that's what you can see here is the word cloud. As we defined 20 words, we have 20 words in here because our topics are described by 20 terms. And the size of each term is associated to its weight defined by the LDA. Means the bigger words are more important and the smaller words are less important. Now, what you can eventually do, you can select one of these words, for example, and then you see all the abstracts itself here. You can now finally read these abstracts. You can have a look at them. You can deselect those that are less interesting for you, and yeah, then you can just go ahead and create a little summary for yourself. The summary is just a spreadsheet containing all the abstracts and all your terms. So this is actually what I wanted to show to you, what we're doing when we're talking about topic modeling. It's basically, we have an algorithm, find the topics for us, and then we can decide which subset of the document we want to have a closer look at, or of the data set, sorry, we want to have a closer look at. And we don't have to read 1,500 abstracts, but maybe just 5 or 10. Okay, and yeah, what else you can do with these information now? So of course you can go ahead and have a closer look, like read those abstracts, really do a deep dive into the extracted topics. Or what you could also do is use these extracted topics and do use them for classifying new documents. But I'm gonna stop here also with the view on the time, and I'm handing back over to Scott. Where do we have it? Oops. Anyways, so.
Yeah, I think I can grab it from you here.
Yes.
So just briefly here, we've got about 15 minutes left in the webinar. I want to take a few minutes to show you one more thing, and then we'll stop and we'll answer some of the questions. I already see that we have some good ones coming up in the Q&A. So shifting back away now from LDA back to the idea of sentiment, I wanted to show you a workflow that is going to be running in the KNIME web portal as a data app. So some of you may not have seen data apps before. I wanted to show you something that's specific to text processing here. This is the KNIME server, and what I could do is I could build a workflow that's intended to be deployed as a data app, send somebody the link, and they can, click on the big yellow run button here, which I'm going to do shortly. And what this is going to do, this is going to create a dashboard for us that is going to grab tweets, live tweets right now from Twitter, to a particular count that we have specified, and we can also say how many of them we want to grab. We have already trained a model using a different workflow to classify these tweets as being positive or negative. So this is set up to go to American Airlines. Maybe instead, let's see what people are tweeting at the Twitter account itself. And instead of 25 tweets, maybe I'll grab 50. Let me move some windows around here. I'll click next. So now KNIME is going to go out using the workflow I built and grab the most recent 50 tweets at Twitter, the Twitter account. And then it's going to classify those using this model that we've already built and show me a summary. So what do I see now? I see a histogram. And so we have, of the 50 that it grabbed, 20 negative tweets, 23 neutral tweets, and 2 positive tweets. So we're missing 5 there that got filtered out for various reasons, which I'll show you in a minute. Why only 2 positive tweets? Well, this is social media and people like to complain. It's kind of the nature of social media. Pretty much any large brand we would have selected here is going to have very few positive tweets. So this doesn't really say anything about the Twitter account in and of itself. And we also have this word cloud over here that talks about what people are discussing when they tweet at Twitter. So just recently, as you probably know, Elon Musk purchased Twitter. And so there's a lot of people who are tweeting at Twitter, for example, Elon Musk. That's all this guy said. So this was classified as a neutral tweet. If I wanted to highlight just the negative tweets, I could click the red bar here. That highlighted everything. That's not what I wanted to do. Let me undo that. What I could maybe show instead is what are people are talking about profiles, automated profiles. So I could control click the different words here, and it's going to show me which tweets as I scroll down mention one of those terms. So this person has a negative tweet. Does anyone respond for support? I don't receive SMS messages. So this person seems unhappy about being able to log in or something. Looks like the model classified that appropriately. But this just gives you an idea of what you could do practically speaking when we build a model, right? It's one thing to build a model as a data scientist and predict something, even if it's very accurate. We want to be able to use that information to drive decision making. So if we build a dashboard like this, we might be able to turn it over to someone else who's not a data scientist, maybe someone who has never seen KNIME before at all, and they help them dig into these tweets maybe with an eye on responding to some of the negative tweets directly, and maybe making sure that that customer doesn't have a bad experience or a bad impression about a brand that we're concerned about, right? So that might be a practical application for something like this. So pretty straightforward in terms of what we're doing. Build the model. This particular workflow runs the model using these live tweets, builds us a work cloud, and shows us the tweets. Now, what does the workflow actually look like on the back end? I'll show you. This is the workflow. So we have to first go and grab the tweets. So inside this gray box, this component here, this Twitter API connector and Twitter search is what's actually going to get the tweets. All these other quick forms over here are basically supplying the different credentials that need to be given to be able to log into Twitter and go grab the stuff. But we get the tweets out using the Twitter search node, and we do a little bit of filtering and so forth. We get rid of emojis because that messes with some of our visualizations that we produce later on. We convert from strings to document, as I mentioned, super important node that we pretty much always have to use in these types of analyses. And then we do some other pre-processing things we saw before, like tagging, case conversion, stop word filtering, number of characters filtering, and so forth. And then once we've cleaned up our data in this middle section, we're reading in a couple of things. This here is the random forest model that is actually doing the classification that we trained already. We're also, in addition, reading in the previously generated document vector space. So the model was trained on a corpus consisting of a particular set of terms. We want to also use that same set of terms in the document vector applier. We're going to apply that to the new tweets, which are unseen by the model. And that's going to be key before we actually try to apply the model. So just making sure that we compare apples to apples with the model that we trained versus the new tweets that are coming in. And then once a tweet is predicted as being positive or negative, that's joined in back downstream. And then we have this visualization node where if I run it here in KNIME instead of on the web portal, it looks very similar, right? Except I ran this yesterday. So the distribution is a little different. The tweets themselves are somewhat different. But same idea, right? So I could generate this visualization, this dashboard, so to speak, within KNIME itself and look at it. And then once I deploy this workflow to the web portal, that is where you see this completely running in my web browser. The person who runs this, right, they don't see anything about a workflow. They just see a big button to start the workflow. They click it, they start interacting with it and go about their business, get the information they need to make decisions. So I wanted to show you a practical example of what a workflow in action could be used for, right? Simple, but useful. Okay, that is what we wanted to show you today. I think that's probably going to be it in terms of the content. I guess, Lisa, you had some wrap-up slides that you were going to share.
Yep, correct. So before we go on to the Q&A, let me just quickly wrap up the session with some information for you. So very important, we have a book. It's called From Words to Wisdom. You can get it for free with this code here. It's available on knime.com/KNIMEpress. And this book covers a lot of these concepts we've talked about today, but even more, and it includes a lot of workflows you can practice on and all kind of use cases. So if you want to really do a deep dive on text mining in KNIME, this is the right place to go for you. Then I, of course, would like to point you to all the channels we have to stay in contact with us. But two things I really want to highlight here are our two courses. We have a e-learning course on text processing. It's in our LMS. And there you can watch some like videos and do some workflow exercises on your own. So it's a self-paced learning course. But if you rather want to have an instructor, we do have an instructor-led online course about text processing end of November. Then one other thing, there's actually another thing I want to mention after that. One thing though, the KNIME text processing nodes are part of its own extension. You need to install that before you can get started. You can either do this via the KNIME AP directly, so KNIME Analytics Platform directly, or the more modern way would be to just go to the KNIME Hub, search for the text processing extension, and then drag and drop it into your IP, and it will install everything for you. But yeah, other than that, nothing else is required, and you can just get started and do all the things yourself with the workflows. And then one very last thing, I'd like to take the chance and mention the KNIME Fall Summit. It takes place November 14th to November 16th, so in 2 weeks. It's happening on site in Austin, in Texas. And there you will have the chance to hear and learn from many, many data and business experts. And with this code down here, join us 10, you will get even a 10% discount on your ticket. And in case you haven't or don't have the chance to go there on site, you can also register to stream selected sessions online. So that's it from our side. So we're going on to the Q&A now, I guess.
Yeah, let's take a look at the questions we've got here. I marked some that we wanted to make sure that we answered live. So I think the first one here from Marcel, I hope I'm saying your name correctly. Apologies if I'm not. They ask about the Twitter example. How do we manage various languages? It would be tricky, I suppose, in the case of Twitter, right, where you're going to be getting different tweets in different languages all at once, maybe. Probably what you could do would be to, if you wanted to parse all those, I would separate them into their different languages and then run different models on the different languages. That's a little bit cumbersome, but I think that's the approach that you would have to take. Either that or you would need to translate them first. And translation is not something that we directly support in KNIME. We actually do have an Amazon translation node, but it's one of the few things in KNIME that you would have to pay for, right? You have to pay Amazon to be able to do the translation directly. So while we have a node, it's not free. So there's a few things you would do there. I think the simpler approach, though, is probably to segregate by language and look at different models for each language. Other questions here. Here's one about the document to vector node from Matthias. He asks, the vector after transforming the data contains all the tagged words as dimensions. Like we showed you before, each term has its own column. He asks, how can I bring the document into a vector in which the dimensions are the different part of speech tags? I thought about this a little bit while Lisa was speaking, because it's not clear to me exactly how that would happen. I think what you would have to do is probably set up a looping construct in KNIME where you filter such that you would, in each stage of the loop, you would filter, for example, adjectives and then adverbs and then verbs and then nouns and then whatever, right? Whatever you're interested in, you would have to filter and run the loop for each of the different parts of speech and then combine the matrix back together and do it manually. The reason you would have to do it that way, I think, because I've never done this before, is that the term to string node in KNIME, there's a node that will take the terms that you generate from the bag of words and give you the actual term. But when you use that node, it strips off the part of speech, or it strips off any tag. So that wouldn't help you. So I think that you would have to build the matrix yourself manually and then do whatever you would want to do with it. Although I was thinking about it and it's not obvious to me what you would do with a matrix structured like that. I don't know, maybe sarcasm detection or something. But anyway, hopefully that gives you a little bit more idea. And if you want to discuss that in more detail, we can follow up with you on the forum. If you post on the forum thread associated with this talk, maybe we can dig into more specifics about what you're trying to do there. And then maybe we have time for one more question here from Gio. This question says, and this was in reference to what Lisa was talking about with LDA. How are the words clustered under a topic? So is it based on the meaning of the words or the co-location of the words, or what is it? Well, it's definitely not based on the meaning of the words, because LDA doesn't know what words mean at all. It's without getting into all the math of it, it's more about, I guess you could think about it as co-location of words. It's the distance of the words to one another in multidimensional mathematical space, which is not something we can visualize very well. But that's more or less what the distribution, there's an underlying distribution that's trying to suss that out. So that's basically how the clustering takes place with LDA. If you're interested in that, as Lisa mentioned, we have a course which goes into more detail it's an L4 text processing course, talks a little bit more about the math and how the algorithms actually work. It's more of a how does it work in addition to showing you, the workflows and stuff. So more detail is available there, but I hope that helps a little bit. We're almost out of time. Are there any alternatives to the LDA algorithm in KNIME? LDA is the only topic analysis algorithm that we support right now with its own node. But if you wanted to use other ones, I know BERT has a topic analysis model that's out there. You could implement it in Python within KNIME, but there's not a dedicated node for it yet. Okay, hopefully I think we've answered most of the questions. If there are any left over, please follow up with us in the thread online, but I'm going to go ahead and wrap it here because we're at the top of the hour. So thank you very much, everybody, for attending. Hope you learned something today. Hope it was useful to you. Come and see us at a future KNIME event or webinar. We'll be happy to chat with you and see you then. But for now, that's it. Thanks, everybody.
Thank you.
Bye-bye.
Bye.